Today we're going to talk about the concept of free energy, or simply delta G. So we all know what that means, and so we're going to start with a very simple reaction that we all know, which is photosynthesis. So we have the sun, and the sun sends light waves, and then we have green leaves, and inside the green leaves a reaction happens, and the inputs of the reaction are, we have 6 carbon dioxide molecules and 6 water molecules, plus that energy. So these are all inputs, and these will give us glucose, C6H12O6. Now, what happened here is that the plant used this energy, and this energy was converted from being a light into a chemical energy. So the first concept, or the first thing that we need to know, is the first law of thermodynamics. So the first law of thermodynamics is the law of conservation of energy. Conservation of energy. That energy cannot be destroyed here in this cycle, in this example that we have, but what actually happened is that it was converted from one form to another. So this is the first point. The second point, or the second law of thermodynamics, which deals with something called entropy. Now, what is entropy? Entropy is a measurement of the rate of disorder in a system. What does that mean? It means that here we have inputs, and one of these inputs is energy. Now, these inputs were rearranged into something else, also including that energy. That energy contributed in that arrangement. And the maximum entropy is where the perfect arrangement of the components of a system are there with a certain amount of energy. So it's variable depending on the system. And in order to calculate the free energy, that we're going to talk about today, we need to know the entropy of a system and to know the internal energy. So we have the energy of the inputs, and we have the energy of the products. So what we do is that we have two sides of the equation. So we have the inputs, and then the reaction, and then we have products. Now, what happens is that we need to know the entropy, which is delta S, and the internal energy, which is delta E. And this for both, so let's say E1, S1, and E2, S2. And what the free energy of both of these sides, each one actually equals the total internal energy minus the temperature in which the reaction happened in Kelvin multiplied by the entropy. When we subtract that value from that value, we will obtain the delta G, which is the free energy. Now, what do we need that free energy for? What does it mean? The thing is, in this reaction, furthermore, we can use this glucose because we are talking about bioenergetics. We were talking about the metabolic cycle inside the human body. So what we need this for is to specify what kind of reaction is that. And here we would have two cases, whether delta G would be positive or delta G will be negative. And by this I mean delta G of both the inputs and the products. So what we do is that we calculate this for the inputs and we calculate this for the products, and then we would have the delta G of the products minus the delta G of the inputs, and we will obtain our total delta G. This is the thing that we're talking about here.